of our journey. I hope it's really been a fascinating journey for you, understanding how we've evolved to become a mobile company, how we've moved into mobile, started looking at different types of apps, figuring out how to build them, figuring out how to design them, figuring out how to organize ourselves to do that. We're going to finish. We've been kind of following our life cycle. We've been looking at the back-end infrastructure. We've been looking at the design. We've been looking at the engineering. It only seems fitting that we should finish off with a session that talks about how we actually release these apps out to the world in massive scale. And this is, I guarantee, a talk you do not want to miss. So, without further ado, I would like to introduce up on stage our release engineering team, starting with Chuck. Take it away.
Hey folks, I'm Chuck Rossi. I lead the release engineering teams at Facebook. I'm also probably the last thing standing between you and an open bar, so I'll try to make this quick and to the point. I've done software engineering and release engineering for about 25 years here in Silicon Valley. I've worked for companies like IBM Research and Almaden, Silicon Graphics, NetGravity, DoubleClick, VMware, Google, and Facebook for the last 6 years. I was all relatively early. I was an early employee at most of those companies. To put it in short, I've seen some ship. I've seen a lot of ship in my day. I want to talk to you about how we ship mobile at Facebook from a release engineering standpoint, but we're kind of famous for how we ship the web software. We release Facebook.com twice a day, every day. And I'll give you some inside information that happens about 9 a.m. Pacific and 4 p.m. Pacific. During that time, Facebook.com is rolled out on new code with anywhere between 30 and 300 changes per push. All right? It's a quasi-continuous deployment system using the best methods of DevOps and continuous integration and continuous deployment and blah, blah, blah. It's gotten so good that I've basically whittled down the team that is responsible for Facebook.com down to 2 people for release engineering. So to me, shipping web deployment, web software is a solved problem. I'm actually very happy where we are with that. But we decided we were going to be a mobile company. So when we decided that, we took all our tools, all our good process, all that good DevOps stuff, all that continuous integration, and continuous deployment, and we threw it away because mobile is dumb. And I hate it. But I can't, right? Because as you've heard, we have over 1 billion people using the mobile products. Today alone, there will be over 600 million people who are going to take out their phone and have a mobile experience. This cannot be dumb from a shipping standpoint. I have to support iOS, which means older iPads and iPhones, means different resolutions. For us, it means iOS 6 and up, which is a challenge. Remember, there's the native app that we're all excited about and want to ship, but remember, for most complex mobile apps, there's a web component, there's endpoints, APIs, there's a back-end component. Those things sometimes have to go in conjunction with each other. They need to be in sync, and need to release those without one breaking the other. Same story on Android. We support Froyo and up, and those of you who support Android, saying you support Froyo is a bold statement. Again, native and web components. And here's the rub on Android. We actually when I ship the one Facebook for Android app, it's 15 APKs. Why? Because I don't want you downloading all those assets you don't need. I build a separate APK for every DPI architecture, whatever I can do to narrow down that APK for just the bare necessities you need for your device, I'm going to do it to lighten the payload. All right? Let's also not forget that it's also other apps. So Facebook is not just the main app. There's Facebook Pages Manager, there is Messenger, there's Paper, there's Instagram, and of course there'll probably be more, right? So there's going to be this stack that we're creating, this deployment environment that we need for mobile. Can't just be solved once, it has to be solved for every app that Facebook comes up with. I want to show you, we talked about this a little bit, but I want to show you kind of visually how we used to develop, how we got into this. Now, we did what was natural here, and I think most people who are in a company that starts from a web presence and goes to mobile does this exact thing. You start with basically your core desktop web team, the experts in photos and events and messaging, whatever they are. They do their thing, and then suddenly, mobile, right? So you do the natural thing. You have an iOS group, you have an Android group, and those people do their thing there. Well, very quickly, and as Tom kind of alluded to before, this doesn't scale. And the main problem here is kind of obvious. You have a lot of people, these are made up numbers, but you have a bunch of people working on kind of the core thing, and you have on the receiving side all the platform experts, hopelessly outnumbered, basically trying to port whatever they do on the photos team into that platform that they're trying to support. So this is going to be a problem for these poor people on the Android vertical and on the iOS vertical. The end result is you don't produce the best product this way. And the reason is obvious. Like I said, you have your platform experts and you have your product experts, and they are divided. All right? So that was the first problem that we ran into. We operated a long time under this kind of way until we fixed it. How we used to ship, again, and this is organic. I've seen our organizations do this all the time. And this is especially true when you're trying to launch your app. Like the first time you're trying to get that app out, you automatically fall into this mode. It's feature-based shipping, feature-based releases, right? By default, that's what you do first time you ship your app. Problem is you're going to fall into that mode every time past that. How does it work? I mean, you decide on the features you want. You work furiously, you iterate, you test, you go back, you iterate back and forth. When everything's done, when all those features are in, you ship your app, right? Problem here is all features are number one by definition. It's a feature-based app. All those features are the highest priority because they all have to get in. If they don't, the release is not going to go. This gets complicated even more when you have this organizational structure like we have. Each team is going to make its own list of priorities. The messages team, the photos team, the events team, they have their list of stuff they need in. They have their number one priorities, blah, blah, blah. Those all get dumped to the mobile teams. Now, the mobile teams have 3 number one priorities. They can't even basically sort between the 3 to realize, is emoji more important than automatic upload, or should I really be worrying about this reply in line thing? After that, they have a whole host of things that they need to get out as well. So this does not work out well. It's especially hard in mobile because it's a very tight cycle in mobile. Things happen quickly. You find yourself reacting a lot in the mobile space. We're also very data-driven in mobile. Actually, we're data-driven across the company, but you can get a lot of data on how people interact with their mobile devices. That comes in real time. You have to make a decision during your release cycle of, oh, shoot, here's a good example. Messaging team figured out that, hey, we're getting data that if we put a green dot that indicates someone's online, we get like an X% increase in engagement. So that has to, they'll go to the mobile team like, hey, we got to get this in. This is a high priority thing. While they're worrying about that, the next day the photos team will come. And the photos team made an assumption about cover photos. When we designed cover photos, the assumption that we had was like, hey, cover photos are like, you're going to use your desktop to set those. It's kind of a big, pretty image. You're going to want to play with it on desktop. You're probably not going to do it on mobile. Well, it turns out in mobile-centric countries, you do want to change it on the fly, and people are trying to change their cover photo on the fly. And it wasn't working well. There's not a good flow for that. So the photos team comes to the Android guys and say, hey, we need to have this right away. We're getting killed in Indonesia and other mobile-centric places where they can't do this. Another problem with this method is you don't know when the code is going to ship, and this is a major crisis. The reason why is because it gets you into this mode here where you're always 80% done. If you don't know when the next ship date is, and we're saying we're finally, okay, we're picking a date, finally, we're going to hit this date, and you're 80% done on your feature, you're going to put it in and launch it because you have no idea the next chance you're going to get. It might literally be 6 months until the next feature release goes out. You're going to land that code because it's good enough. All right? So I think we suffered under this on our first iteration of mobile years ago when we first started doing mobile apps. This is exactly what happened, all these problems that we sat. And this drove me nuts. It drove my whole release team nuts. It's like, how can we be so good at web and be completely inept when it comes to shipping mobile apps? Right? We can solve this. So we looked at what we do on desktop web, and we figured, okay, what can we do to apply to mobile here? The first thing was obvious, and Tom talked about this. Take that stack, take that siloing of the teams, and crush it organizationally. The way we work now is there are no columns of iOS developers and columns of Android developers. There are photo developers, there are events developers, and there are messages developers. And they work across all platforms. And if some new crazy platform comes up, they will support that as well, just as they do all the others. So now the product experts are on each platform. And they are the experts. They have a passion for photos. They love stuff about messaging. All they want to do is make messaging better, and they worry about everything across the entire fleet of devices we support. Now, we did not get this for free. It's an organizational hit, a lot of shuffling of people, stepping on feet. So there is a bump you have to hit to get past this. But I'm telling you, it was worth it. Kind of some of the proof that we have, that inflection point is kind of after we did the reorg. These are the number of unique developers checking into the mobile code base. So you can see quite dramatically it kicks up once we had everybody basically working across all platforms. So how do we change the shipping culture? That's kind of the development culture. The shipping culture now is based on a date-based system. Date-based releases, and you folks know plenty of companies, Chrome and Firefox and Mozilla, and a bunch of people basically use date-based systems. So here's the rub with a date-based system. Whenever you're trying to ship, you have three things you're worried about. You have the quality, you have features, and you have the schedule you're trying to hit. Under a date-based system, you get to pick two of these. The two you always pick are quality and schedule. Features are the first thing that go out. All right? The reason why is that date is absolute. We ship on time. I can look at a calendar right now, and I can look at for the next 12 months, I will point to the day that iOS and Android will ship to their respective stores for the next year. All right? And that's set in stone. Now, there's good news and bad news about this. The good news is if you get your stuff in, if you make the branch cut and your feature and your code landed, you can make a pretty good, you're going to be very confident that your thing's going to go out. So that means your press release, any press cycle, any announcement, any back-end services that have to come up, any endpoints that need to be there, you have a date you can count on. It's going to happen on that day. And my release team does a lot of work to make sure that does happen. Like I said, the bad news is I'll talk about it a little more, but the bad news is if you don't make that cut, you're on the next train. Another principle here, we're like doctors, do no harm. We have core metrics on mobile that cannot regress. Things like TTI, time to interaction, crash rate, star rating. A whole slew of core metrics are checked and checked and checked during the entire release cycle. If they regress, that becomes the priority to fix. Not what features are going out, the priority becomes that quality. Basically, are we getting worse? We need to fix it. We cannot get worse on mobile. And again, this is because we came from a bad place in mobile where we probably weren't considered the best app on mobile when we first did this. And we are not going that direction again. It's going to get better with every release. Third principle, there's always the next one with a date-based system, and you know exactly when it is. I cannot tell you how much this alleviates all sorts of tension and pressure and conflict within the engineering and product organization to know when they get their next chance. So if I'm a hard ass and throw people out because your stuff's not ready, or the quality, you just hurt quality, you're out, it's not a big drama because they know like, oh, well, I'll just get in the next one. In fact, the ultimate example of this is web. Web goes out twice a day every day. If I throw someone out or there's an issue and they're like, hey, this is a big thing, I need to get it in, not today you don't, it looks like junk. What's the problem? In a few hours, they can try again because that push is going every day, twice a day. So this is kind of my favorite thing of these things, is that it relieves any sort of conflict because you know when things are going to happen. Finally, the fourth principle here, you retreat to safety. My team's responsible for that release branch, for that product. If we have any indication that we're not doing well, that things that have been added are not good, it's reverted. We throw stuff out, okay? If we get in a situation, we have to be very subjective. I know this guy here, he puts in 5 changes. It's after the cut, it's a little late, it's kind of featurey, but generally, okay, I look at it, I look at the code, okay, I think this can go. We put it in. It doesn't work. He comes to me the next day, I just take these 3 more changes, I swear to God it'll work this time. No, it's gone. So it's reverted, it's out, and that's our default case, is like, we just want to keep that stability in release. If there's any doubt, we remove it. In fact, my favorite quote is from this movie, Ronin, where Robert De Niro says, if there is any doubt, there is no doubt. So that's kind of our mindset there. All right. This really depends on having a strong release engineering team, because that team is kind of making the call on what can go and what can't. More organizations, I do a lot of talks with a lot of companies, kind of one-on-one, and more organizations have strong DevOps release teams. If yours doesn't, get it there, because you want your release team to have the experience and the skill set to make these subjective decisions in real time about your product going out. All right, let's get into the mechanics a little bit. Here's what we do on web. Here's the development flow using whatever crappy source control system you want. This is what we do on desktop web, on Facebook.com. You've seen developers, as developers, you've screwed up source control for many years. I've seen it with Perforce, Git, Mercurial, CVS, Subversion, all of it, right? You can make it really complicated. At Facebook, it could not be simpler. You make your code somewhere on whatever goofy system you want to use, you check it into trunk, and you are done, okay? That is your process. On web, we take 1 week of development. Generally, it's Sunday at 6 p.m. We cut a simple release branch. That release branch lives internally just to us from Sunday to Tuesday. That's the blue period there where we stabilize it and we make sure things look good. If everything looks good, on Tuesday around 4 p.m., we do a massive weekly release. That push, the weekly push, is between 4,000 to 6,000 changes that go in for 1 week's worth of development, all right? So that's the one day I don't do 2 pushes, I just do 1 big push. That's the sweep up of everything in master that goes out. After Tuesday, on Wednesday, Thursday, Friday, Monday, that's my 2 push a day system where I cherry pick anywhere between 30 to 300 changes, like I said, all right? That's the flow of Facebook.com for at least 6 years. Let's overlay what happens on mobile now. Notice not much has changed. The time scale is different. So now we have 4 weeks of development. So we're on a 4-week release cycle on mobile. When that, at the end, basically the day I ship the mobile apps is the day I cut that new branch with that red line. We stabilize that branch in that blue period for 3.5 weeks. We get it so everything works. We take about, I want to say, 100 to 120 cherry picks during that 3-week period. And then that green period, we soak it. We don't touch it, let it gather state, let it run for a while in dog fooding, and see if it stays up and healthy. And then on that 4th day of the 4th, after the 4 weeks, we ship it up to the respective stores. All right. So the nice thing here is no matter where you work in the organization, you're always under the same kind of regime of checking into trunk, simple release branch, cherry pick 4 things you need, ship on a date, ship at a fixed time. All right. As Jenny mentioned, we have a secret weapon on Android, which is awesome and puts Android really kind of ahead of things here. We have the alpha and beta programs. A little bit more specifics on that. I have a couple million people who have signed up for the beta program. What they get is off that blue line down there. As I'm stabilizing my release candidate, they're getting that build every Monday, Wednesday, and Friday. All right, I ship it out to a couple million people. Most apps will never have a couple million people as users in total, but those are my beta testers. Think about the data I'm getting back in aggregate from a couple million people using my nightly build, my release candidate build 3 times a week. So I have dashboards and things that extract that aggregate data into graphs, and it graphs it over the production values. Things like crash rate, TTI, all the core metrics I care about are graphed against production. Any variations I can see right away. That works so well, we kind of quietly opened up an alpha program. What is alpha? Wrap your head around this. I am shipping whatever's checked into master to a couple 100,000 people every night on Android. That's either awesome or terrifying. I think it's pretty awesome. It's worked out pretty well. So that is a much more, let me show you a picture here. I mean, that alpha is a much more aggressive thing to do, and it really is your canary in the coal mine situation. Every night, I mean, if you're a developer, think about it. You check in code, and that night you can start getting data of any logging, of any metrics, of any experience right away. As a release engineer, and I'm looking at that aggregate metadata, if there's any variant day to day, I'm going to start catching it. And it's, like I said, it's a very early indicator of things going bad. When that canary falls over dead, I'll show you what the graph looks like. You can react immediately, right? Just for your information, here's a sample of the countries that my alpha program hits. These are the users. It's US-centric a little bit, US, Great Britain, but it's a pretty decent slice of worldwide activity using that alpha program. And here it is when the canary dies, right? These are the active alpha users. You can see the first circle, we just shipped something bad. And usage went down, so the alpha users kind of bailed out. And then we fixed it, and you see it ramp up again, right? I'm sorry I can't show you more detailed graphs, but like the highest level, at least you have this, right? The usage will immediately tell you, like, oh wow, I better go check those other graphs because something really went bad there. The beta program is more of your crystal ball, and it's going to tell you kind of more long, by the time things get into the release candidate, they are pretty stable. So they're just seeing like, okay, within the next week or two, what are you going to see? And again, the distribution here is pretty reasonable. Again, a little US-centric. The other problem with your alpha and beta, and keep this in mind, and it's kind of obvious, is the user base. When we get the telemetry of what devices they're using and what networks they're on, they're all pretty modern, right? The people who opt into these things are kind of into technology. They're going to have newer phones. They're going to be on better networks. So it's not, while it's not the most perfect distribution, it's a very good distribution. All right, I'm going to hand it over to Christian, who works on my team. I just gave you a very high-level view of some very important meta things that we did to make mobile bearable. And there's still a lot to do in mobile. I am not happy at all after doing software engineering, software release for umpteen years. I'm not happy where mobile is right now. The ecosystem needs to change. Google and Apple need to help us do this. I told you I'm on a 4-week release cycle for mobile. I am not happy with 4 weeks. It still leaves enough tension between the PMs and the devs and me to say, like, you know what, this stinks, you missed the cut, you're out. That could be an 8-week sentence, right? If they just missed the cut, 4 weeks to ship the current one, they get it to the next release, 4 weeks to vet it, and then it ships. I agree, that's too long. My goal in life is to get, by the end of this half, down to a 2-week cycle on Android. I want to ship the Android app every 2 weeks, all right? And I know we can do this. It's a matter of also the ecosystem needs to kind of come up with me to do this. And if I get it done, it's going to be better for you. Because believe me, when you start getting into fast iteration cycles for your apps and you want to get stuff out in front of people, you don't want to wait. And I certainly don't want to wait. So let me hand it over to Christian, and he'll tell you more about the tools.
Thanks, Chuck. My name's Christian Legnitto. I'm on Chuck's team at Facebook. I've been doing releases for about 8 years now. Before Facebook, I was at Apple doing macOS 10 releases, and after that, I was at Mozilla doing Firefox releases. So I, too, have seen a lot of ship. I'm going to tell you about how we write code, specifically mobile. Mobile's really young right now, and some of the tools just started to fall over at Facebook scale, and some of the ecosystem just wasn't prepared to move as fast as Facebook moves. But first, I want to set some context. Our Android and iOS repositories have about 100,000 commits. We've been in this game for a long time. We had one of the first iOS apps and one of the first Android apps. And as Chuck mentioned, we have a lot of engineers contributing to these apps. We also have about 150,000 files in our mobile repositories, and those aren't all Facebook files. We vendor in our dependencies as well. And as Chuck mentioned, we're not just the main app. We have at least 10 apps in the repository that are under active development. Believe me when I say, I've worked on both a web browser and an operating system. The problems Facebook faces are just as big as the problems an operating system and a browser face. Okay, so you're a new engineer at Facebook. You have code on your laptop. You're like, yeah, I have this great new feature. I want to stick it in the mobile apps. What do? Do you just land the code in the mobile app and it goes out to 1 billion users? Well, not really. We want code to ship fast, but not that fast. You have to do one thing, and that's code review. Facebook believes in code review. It's good to get a second opinion about the code you're writing. Code review also gives you a place to put metadata about the code. Did the test fail? Did the test pass? Was there a lot of discussion on the diff that may make it so you don't want to cherry pick it into a release branch right before release? It gives you a place to have those discussions before it gets into the tree, not after the tree. So this here is a screenshot of our open source code review tool. It's Fabricator. That's its name. We wrote it because we needed it, and you can find it on GitHub. You can see that Matthew saw the test failure as a reviewer, didn't spend a bunch of time on this diff, and just said, okay, don't put this code in the repository. There's a test failure. Figure it out. Now, you don't have to use Fabricator. There's a bunch of open source things that do this, even paid companies. GitHub has a way to review if you have the pull request model. We're partial to Fabricator, not just because we wrote it, but because this is one killer feature. Code macros. So they're basically photo comments in a diff. And sometimes as an engineer, especially when you're working with more senior engineers, it can be hard to say, hey, you actually should put a test here. Or that was so awesome, I want to do more than just say good job. And this is sort of silly. It's obviously not going to change the world, but this stuff matters. As Chuck talked about, culture is very, very important, and being able to call out someone and say, I need more tests, without sounding like their mom is really, really important. So what do we do when you put up a diff? When you write your mobile code, what do the machines do? They do a lot, because we don't want humans doing a lot. Human time is very, very expensive, and machine time is relatively cheap. So when you have a code change, we try to make the machines tell you if it's good or bad. So you put your diff up, and rather than you having to build Messenger, Pages Manager, Facebook, to make sure everything works, the automation builds it for you. We build ARM, i386, every variant you can think of. We also run linters and static analysis on your code. And these range from everything like regular expressions, where we'll look at the code and say, hey, you used a function that matches this string, don't use it. It has bad performance. And because they're regular expressions, they're really easy for someone to write. And that means that you don't have this tribal knowledge. You don't have all the new engineers you're onboarding tripping over the same problems. The tools say, hey, you use this function, you shouldn't use it, and here's why. And of course, doing regular expressions over source control is sort of dumb. So we have the other layer that actually understands the code and the associated tooling. So for example, Clang linters can call out on an iOS diff, hey, you have a memory leak here, go fix it. And that's something that the reviewer doesn't have to actually catch. The machines tell it, and the reviewer doesn't have to spend time looking at that and can move on to the next diff that is ready to review. Facebook wants to move very, very fast, but we also want high quality, so we heavily invest in testing. The whole test pyramid with unit tests, integration tests, and snapshot tests. So snapshot tests are very interesting. You take a screenshot of a known good view in your app, and then a screenshot of the app with your code change, and you compare them. And if there's any delta, there's a bug, or at least something that needs to be investigated. When do we run all this stuff on your particular diff? The answer is all the time. If you're an engineer and you don't want to sit there locally building Messenger and Facebook and all that sort of stuff on your laptop, you can send it up to the compute cloud. And you can say, hey, run this on every variant and tell me if it's good or bad. And then if you think it's good, you put it up. You want a human to take a look at it. You create your diff. We run it again just in case anything's changed. And if your reviewer wants some changes or you found something that was wrong, when you update the code, we run it again. And let's say our code's all good. It's ready to land. You can put it in a commit queue, go out to lunch, and the machines will build it, run all the tests again, and land it if it's green. You don't have to sit around and do that. And then once it actually makes it into the tree, we run these yet again. We are firm believers in CI and making machines do the work of humans. We run about 50,000 CI jobs every day. Actually, a bunch more, but so we're heavily invested in this. How do we do this? Well, on Android, it's pretty simple. We use our Open Compute Linux boxes that we have that serve the Facebook.com website. If you have Android, if you're not doing CI, we would highly suggest it. You don't need to have a big data center like us. There's a bunch of services, and even just having a Linux box or two under your desk is better than nothing. On iOS, this is a little bit of a harder problem. You can't just grab a Linux box off the rack, throw Mac OS X on it, and scale. So when you're smaller, when you're first starting out and you see the benefit of continuous integration, you generally start with a Mac Mini or a Mac Pro at your desk, or maybe you get someone's laptop and they're the person that has slower experience because they run everyone's builds, but that obviously doesn't scale for a company like Facebook. So what we had to do is we had to rack Mac Minis in our data center. So we do not want to do this, but this is what we had to do. And so we have racks and racks and racks of Mac Minis in various data centers. And we do that, and that was worth the pain of getting them in the data center, figuring out how to rack them, figuring out the different power requirements. We do that because that's still better than having an engineer do all this. We don't want humans waiting on computers. We want computers waiting on humans. So let me talk to you about a couple problems we hit and the solutions we came up with and share them with you. So let me talk to you about how Android was. We, again, have one of the oldest Android apps. And as such, we have one of the oldest Android build systems. It was Ant-based, and Ant worked. It was good. It's a natural Java build system. And over time, it started to get cruftier and cruftier as build systems go, and no one wanted to touch it. So it became a lot easier to not touch the build system and instead just kind of put all your code in the same module. So our dependency tree started to look more like a dependency bush. And probably some of you guys are in this state. It's a natural state of things to devolve to. So a product engineer came to me, actually Michael Bolin, he was working on Facebook Home, and he said, hey, this is a problem. And I said, I agree. What are we going to do? And he said, we're going to write a new build system. And I said, that's stupid. Because that's the proper response for someone who comes up and says, I can write a new build system. You're like, that's crazy. There's a bunch of other stuff out there. There must be something better than what we're doing, and let's go grab it. He persevered anyway, and it turns out his build system is awesome, which you don't say about build systems very much. It is now something critical to the way Facebook does Android development. So the build system he originally started, which we now support as a company, is Buck. Buck is a build tool, and the number one feature about Buck is it's fast. Remember, we do not want engineers to sit there, hit compile, wait a minute, and then come back, oh, it didn't build, wait a minute. Like, we do not want that. So Buck's focus is to be as fast as possible so humans are not waiting around. It's scalable and extensible. If it scales to Facebook, chances are it scales for you. And it was written as an Android tool, but it's not Android specific. It has support for generic Java projects as well. So why is Buck so fast? Well, the first reason is not even specific to Buck itself. We noticed that when engineers are developing code, 97% of the build work they're doing is repeated. And that's not saying these people are not productive, that they're doing all the same work. It's saying while working on new work, while they're iterating, they're building a lot of the same stuff. And it turns out it's about 97%. Think about it. You're working on a feature, you write a couple lines of code, you do a build just to sanity check, you write a couple more lines of code, you check it on a device. The vast majority of the app is not actually changing. And even between your two builds, the vast majority of your changes are not actually changing. So what's the answer? What does Buck do? Well, it's simple. We cache it. So we locally cache your build artifacts, and it turns out this is really, really fast for the individual developer's case. Some tools are not smart in this, and they use file modify time or stuff like that. And what happens there is when you switch Git branches, of course, a bunch of files get modified, so you have to build a ton. And Buck doesn't have that problem. So Buck's fast for the individual engineer use case, but we don't have a single engineer. We have many, many engineers contributing to Android. And we noticed another thing once we had Buck, that 97% of their work collectively is repeated. Again, this is build work, not feature work or anything like that. And so what's the answer there? Well, the answer is actually exactly the same. Cache it. So Buck can talk to Cassandra, which is a distributed database system that Facebook open sourced. It can talk to Cassandra and share build artifacts between team members. So Buck first goes to your local build cache and say, hey, did you build it locally? Cool, just use that, don't bother building. And then it goes out to the network and says, hey, did someone else on my team build what I need? And 97% of the time, they have. So still you get one unlucky schmo that occasionally has to build the world or has to build that individual module. But remember, we want machines to do the work, not humans. So we can actually be smart about this, and we can take our CI system, which is kind of always on the bleeding edge, and we can just prime the cache. So for that 97% that all the engineers are sharing, a particular engineer doesn't have to build it. The CI system has already built it as soon as it checked in, throws it in the cache, and when I rebase to master and I build, it's already there. It's basically a free build. Buck also does some other really cool stuff. Number one, it knows the state of the world, so it can take shortcuts and only do the minimal amount of work. Buck's lazy, yet fast. It turns out Buck is so good and offers a bunch of makes you want to make reusable code modules that some of the generic Android tools started to fall down. So we had to fork Dalvik to optimize for merging a bunch of small libs. We have the opposite problem. We have so many small reusable libs that we needed to handle that. But I think that's a good problem to have. It's a Java build tool, so it's smarter than just doing file m times, and it can go, okay, this file changed, but the Java ABI has not changed, and then it can go, okay, I don't need to build the dependencies, and it can shortcut there. And it's also an Android build tool. So a common thing that you do on Android, you build your code, you build your UI, you load an emulator on device, you look at it and you go, oh, that's a pixel off, or I need to tweak that, and build it, load in the emulator, tweak a UI, oh, it doesn't look good on a Gingerbread device. This is like a common cycle when doing UI work. And why do you have to rebuild code when doing that? It generally doesn't happen. You're generally just tweaking resources. And so Buck is smart when you are just changing Android resources. It knows about it and can take a fast path and do a lot faster builds. And then again, you're an engineer, you're in your IDE, you're typing, you stop to think for a minute and you go, okay, I need to build, I need to make sure this still compiles. Well, Buck actually has a daemon that sits in the background that watches file changes and kicks off builds. So hopefully by the time you, as an engineer, have even thought you need a build, Buck is already done, or at least partway through. And that's really great. So I am going to show you some graphs. This is Instagram. We started 2-minute build times, which is not great. Instagram is complex, but it shouldn't take 2 minutes. That seriously slows down engineers and slows down the company. And then after Buck, we are sub 15 seconds build times. And this is not in a test environment. This is P50 user data back from our engineers. We track every build our engineers do, how long it took, what machines they were on. So this is real data. This is engineers feeling the benefit of it. That's over 8 times faster, which is absolutely huge when you're at a small team and massive when you're at a big team. Don't trust me. It's an open source tool, so people have picked it up in open source. The Garrett Code Review open source project has picked it up. They switched from Maven to Buck. They reduced build times by 67 to 98%. And this is not even using that distributed cache. And they improved reproducibility of their builds, maintainability, and developer happiness. I would say this is the best quote you're ever going to see about a build tool. In any case, this is open source. We built this. We think it'll work for you. We want your patches. We want you to use it. Go check it out on GitHub. Join the community. Switching gears a little bit, we have iOS. Now, Apple tools on iOS are pretty great, actually. But they're usually made for teams of 1, 2, 5 people. They're not made for engineering teams at Facebook scale. So we ran into a bunch of problems. And some of them were because the mobile ecosystem is just young. So some of them were just bugs we had to wallpaper over, and some of them were just inherent in the tools themselves. Like I said, we really like CI. We really want builds fast. We really want engineers to get feedback back on their diffs quickly. So we had to create a build tool for iOS as well. It's a little different than Buck, though. So we created the build tool. It's called XCTOOL. It stands for Xcode Tool. We're not very good at naming things. And what it is, it's a drop-in replacement for Xcode build. Actually, when we first started this project, the same unit tests you ran in Xcode using Command U would never get run when you called Xcode build. It was arguably a bug, maybe a design choice, but that didn't work for us. To have engineers going Command U, machines aren't going to do that, and we want machines to do the work. So it fixed that bug. Luckily, Apple has fixed it since Xcode 5. We also added nice extra features to help with CI. If you've ever looked at the output of Xcode build just basically barfs everything it does onto the screen. And then you have to use regular expressions to parse, did my test fail, which test failed, where did it fail? And there were actually even bugs where tests would fail and Xcode build would return 0. XCTOOL also is faster running tests. Now that we have our code kind of in the development pipeline, we can do a bunch of cool, smart things. So there's not really a good way to demo a build tool, but I'm going to show it to you anyway because the output is way prettier. And this is sort of silly, but it makes a difference for an individual engineer, and it stacks up over time when you have a lot of engineers to be able to quickly look at output and say, oh, that's where it failed, that's what's going on, I can go load Xcode and tweak it. You don't have to wade through a bunch of stuff. And then, like I said, we want machines to do the work in continuous integration, so we actually provide structured output. So we don't have to have brittle parsing, and when Apple updates Xcode, we don't suddenly have to figure out what's wrong in the regular expressions. It's JSON, it's solid, and it works. Okay, so how does XCTOOL work? We didn't re-implement everything Xcode build does. Like we said, the tools are pretty good, they're just a little rough. We wanted a nice sheen on it. So we actually use Xcode build, but we inject our own code into Xcode build. Everywhere it would barf out crap, we barf out JSON. We return the right code when things fail, and we generally are putting a nice sheen on top of Xcode build and XCTest and send test kit. So I want to talk, I don't have numbers on these graphs, I apologize, but I want to talk a little bit about, this is at a high level, and the rates are correct about what we've done and what XCTOOL has helped us with. So first of all, you can see there's 3 stages. There's build tests, and there's run tests. When you use Xcode build, when you use Apple's tools, you can't build test and run test separately. It's all in one. You basically say test, and Xcode build goes and builds them and serially runs them. With XCTOOL, we can split those in 3, and I'll tell you why it's important in a second. So let's go on the build one. So we had our build times, we were chugging along, then we turned on Ccache, and our build times plummeted. If you're using iOS and you're not using the open source Ccache, check it out. It's really awesome, obviously. So we were running it, and we started to see machines wedge. We started to see our CI machines start to go down. Those Mac Minis were becoming unresponsive. And we investigated it, and it ended up being a Ccache bug that happens about 1 in like 10,000 builds. And so we tracked it down, wrote a patch, pushed it upstream to Ccache. They took the patch, then we turned Ccache back on, and you can see at the end our build times plummet. We also build tests separately. And because we are building tests and we have XCTOOL, we can make build tests smarter. We can pin building tests to the same machine that built a binary. Because the tests and the binaries use a lot of the same code, you get a lot of cache locality on the same machine. And you can see we had a high build tests, we got smarter build tests on the same machine, and it plummets about 2 times faster. And then, like I said, we run lots and lots of unit tests, simulator tests, application tests, snapshot tests, you name it. And we were starting to notice that our test runs were becoming the bottleneck. That is both a good and a bad problem to have. Good because you have lots of tests, bad because you want to encourage people to have lots of tests, and again, you want humans to move fast. So XCTOOL actually can run tests in parallel. We added this. This is something Xcode build does not have. And you can bucket up your tests into how many group you want, and then pretty much your test time, the length it takes, is your longest test. And you can see we got about a 2.5 times speed up doing that, and we're not even using heuristics. We just did a dumb, like, okay, bucket 20 tests at a time. So there's definitely more fruit there to get. XCTOOL is open source. Again, we hit these problems. We've solved some of these problems. We want to give it back. We don't want you guys to have to spend the work doing the same stuff. Join us, write bugs, write patches. If you have open source iOS or Mac libraries, or you use Travis CI, you are already using XCTOOL. XCTOOL is the default tool to build when you use Travis CI, which many open source projects do. We're really excited about that. All right, I'm running a little late, so I'm going to kind of go through this. Let's talk about crash reporting real quick. A friend at Apple used to say this to me. When you ship to millions of people, 1 in a million bugs happen all the time. Now think about when you're at Facebook scale with billions of users. We'd like the app to never crash, but sometimes it does. And when it does, you get a stack trace back. Hopefully you guys know what this, but this is a stack trace. And this is a bunch of addresses that humans can't really read, right? So what you have to do is you have to, on iOS, run it through this tool that's called A2S that converts addresses to strings that engineers can look at, tools can bucket on, and so on. This is actually an Apple bug, so we can't even get rid of this crash ourselves, but we can count it and we can go to Apple and say, hey, this many users per day is hitting this bug, and then they can act on it as appropriate. So there was a problem at Facebook scale, and this is a big company problem. Chances are you guys are using a third-party solution or Apple's tools or whatever. You have to do this on Mac Minis. And at Facebook scale, sorry, not Mac Minis, on Mac OS X, which for us is the Mac Minis. And at Facebook scale, that means we couldn't symbolicate everything. So we wrote a tool. It's called A2SL for Linux. Again, not very good at naming things. And that allowed us to get symbolication off the minis onto the Linux boxes and allowed us to symbolicate everything and count everything. And again, it's a big company problem. Chances are you don't need this. You use a third-party solution. But it turns out no one else open sourced their solution. So we decided to. So this should be a solved problem, and hopefully no one else has to do this again. So as I mentioned, we changed how we write code. We hit some problems, we built some new tools, and we open sourced it. And as Chuck mentioned, we changed how we develop. We changed from a web company with a mobile habit to a mobile company. And then also we changed how we ship. We changed from feature-based releases to date-based releases. But one thing we did not change is our culture. We want to move fast, we want to make machines do the work, and we want to ship our code to the world as fast as possible. Thank you very much.
I'm afraid we don't have time for Q&A, but again, Christian and Chuck are all going to be both going to be waiting at our table. So ladies and gentlemen, that is the end of our Hackaway track. We hope you had a really enjoyable afternoon, learned a little bit more about how we build what we do, and I hope you got an insight into the way that we work here at Facebook. All of the videos will be online, and we look forward to seeing you on GitHub. Thank you.